Are we okay? Okay. Can I turn this up a little bit? It seems like the PA is not very loud.
Hey, Jeff.
Hi.
Is there anything new?
Not substantially.
I emailed you. I never got a reply from you. I want to know, I'm looking at a different version for the iPad.
I've been working on it. It hasn't been released yet.
Oh,
Yeah.
when you
Just needed to make sure the PA was loud enough.
Okay.
Is it this or this?
Actually, both of them, we're streaming live audio.
Right.
So I have a separate signal going to your head. This is controlling the house PA.
Yeah.
And then I was just going to pass this mic around for a QA.
Okay.
For the audience to talk back.
Okay. All right.
when do you think it's going to be released, right?
I'm not sure. I've been working on it very slowly, but
Yeah, because I emailed you and you never got a reply from me.
okay.
Yeah, I'd just like to make a quick announcement. Please do not use the Wi-Fi while you're in this room. And
Yeah, the answer
do not
is,
watch the screen while
not
you're
yet.
watching it live.
Yeah.
Okay, because that will cause me much problems.
Do you need a audio feed from the
No, I
computer?
don't. I don't.
Okay, that would need this, just in case.
Okay.
Both mics.
All right. All right. Well, good morning. Let me just make sure we're ready to start here. My name's Jonathan Taylor. My call sign is K1RFD from Ridgefield, Connecticut, about an hour and a half north of here. And it's a pleasure to come back to HRU. The topic is not only EchoLink, but also internet linking for amateur radio in general. And this is substantially the same as a presentation I've given in previous years, so it may sound very familiar to you if you have heard it before. The systems have been quite stable over the past several years. Just a few modest improvements and changes, and certainly some updates in usage and statistics. But I hope that, especially if you are new to the concept of internet linking or EchoLink, that you'll find this very useful. So I'm going to sort of give an overview of these systems with a special attention paid to EchoLink. These are internet voice gateways, systems like EchoLink and IRLP, that let amateur radio stations connect to each other over the internet. And the idea is that this forms a hybrid between our RF technologies and our digital internet technologies. Not a substitute for amateur radio, a supplement to it, a way to enhance the experience that we have, and especially the way we can serve the public. There are other systems which are intended to be amateur radio simulators, and that's not what this is. This is pure amateur radio supplemented by the internet. Examples of these are EchoLink and IRLP. You may have heard of a system called EQSO, although I believe that's pretty much defunct now. And also I'll talk a little bit about the All-Star Link Network, which is based on Asterisk. In the past several years, EchoLink has continued to grow, not nearly as fast as it did in its early years, about 10 years ago, but there are about 5,700 nodes typically online. More than 600 of them are shared with IRLP, so these are nodes that will operate either as an EchoLink node or as an IRLP node. Lately, I've done a lot of system enhancements on the server side, which are pretty much invisible to the user base, using the Amazon Elastic Compute Cloud for many of the servers, which is a cloud computing platform which makes it cheaper and more reliable to run the server network. And also have released a couple of versions of EchoLink both for iPhone and for Android devices. And this is the fastest growing segment, by the way, of the user base is on the mobile devices, similar to other internet services. There's also a second edition of the ARRL book on internet linking, which is available from the League. There are many different ways to use EchoLink, and I think what happens is sometimes we sort of get ourselves in a mindset about a single way to use it. There are actually multiple modes. And the simplest one to describe is what I would call simplex RF linking. In this diagram on the left-hand side and the right-hand side, we have an EchoLink node, which is really just connected to a transceiver tuned to a simplex frequency. On the left-hand side, it happens to be on 2 meters, and let's pretend that station is in Connecticut. And on the right-hand side, on UHF, a station in Sydney, Australia. Identically configured, a transceiver, an antenna, a linking interface, and a PC connected to the internet running EchoLink. The software and the system allow these two stations to connect to each other, forming sort of a wormhole between mobile stations in Connecticut and mobile stations in Australia. And the idea is that when they're connected, they have no idea. It's very transparent to these operators once the connection is made. A variation on that is if you substitute both sides of this equation with a repeater. Rather than having a transceiver tuned to a simplex frequency, it is actually tuned to the frequency pair of a local repeater, or possibly even connected directly to the repeater controller. This way, we have not only the basic repeater coverage in each area, but also, again, sort of a wormhole connecting them, so that the range of this sort of super repeater becomes the combination of the range of the repeaters on each end. Again, extremely useful for sort of ad hoc extension of communications. And then a variation on that is what you may be familiar with if you've used EchoLink on a PC or on a mobile device, which is sort of the left-hand side here. That as long as you have a PC or a mobile device that has internet access and a microphone and speakers and the EchoLink software, you can connect from that directly to any node in the EchoLink system, which gives you essentially remote access to this large network of repeaters and simplex stations around the world. Those are sort of the three different modes. It is also possible to have more than just a one-to-one conversation. It's possible to have a conference where there are multiple stations connected. In this case, 3, but this could be 3, 4, 5, 50, 100, all by taking advantage of the conferencing features of the EchoLink software or the conference nodes, which accomplish the same thing. They function as a sort of a reflector, where in this case, every station in this diagram can hear every other station. It becomes one giant sort of party line. Again, useful for many different types of communications. The fundamentals of how this works are really boiled down to the fundamentals of digital audio. You may not realize it, but the sound card in a PC is really an analog to digital converter, which just happens to operate at audio frequencies. So it can convert an audio frequency signal into a stream of binary data, a stream of bits. And it can go the other direction, take a stream of bits and convert it back into an audio signal. That's the playback function of a sound card. And to make this happen, it's necessary to sample the analog data at twice the highest frequency that you want to capture. This is the Nyquist theorem. So if you want to capture audio up to 3 kilohertz, you need to run your sampling at least 6 kilohertz. Each of these samples is converted, just as an analog to digital converter will do, into a number proportional to the voltage. So let's just look at this from sort of a standpoint of an, of an oscilloscope. If you took a scope and connected it to a sound system like this, and I spoke into it and just said A, 350 milliseconds from left to right, this is what you'd see. It's an envelope. It's a complex waveform. But if you magnify this, if you zoom in on it, the way a sound card looks at it looks at it as a series of regular positive or negative numbers along this complex waveform. These are samples that the sound card is taking. So at every interval here, which looks like it's much less than 1 millisecond, it is capturing samples of this waveform and storing them or transmitting them as digital information. This is just fundamentals of how a sound card works. So we can use this to create a voice over IP system, voice over internet protocol, a term you've probably heard many times. But with this arrangement, we have two computers that have some kind of digital connection between them, let's say an internet connection. Each of these computers has a sound card, which can take audio in and audio out. So audio in on the left side gets converted into a stream of bits, gets sent over to the other computer, and then just the reverse happens. It reconstructs the same audio signal. If we do it in both directions, we have a full duplex or semi-duplex two-way communications channel. All we need to do then is add a transceiver to each end. We have an audio connection over the internet. We just connect that to the microphone and speaker jacks of our transceivers, and what we've created is an RF connection between the two. So sort of by putting in layers, we've created that kind of a system. And the idea of this can be thought of as RF for the last mile. We're creating a hybrid communication system. We use each of our technologies to the best advantage. The internet gives us this reliable, addressable, long-haul path between nodes. The nodes themselves provide the interface, the gateway between internet and RF. And then our existing infrastructure of VHF, UHF, FM portables and repeaters gives us the last mile between these nodes. So we're using each of these technologies to their best advantage. That's the whole idea. Just a review of some of the popular systems. EchoLink is the largest. It actually has more than 210 now registered users worldwide. IRLP continues to grow, and I'll talk about that in detail a little bit later, and also the All-Star Link system, which has some possibilities for customization. And I think these systems all complement each other pretty well. First, a word about EchoLink. This was not an adaptation of some other system. This is actually built entirely from the ground up for amateur radio. You'll notice that the usernames in the EchoLink system are amateur radio call signs. And the whole thing is designed around QSOs and connections and things that are familiar to us. It was originally designed for compatibility with another system that was around about 12 years ago called iLink. And there was a lot of discussion in those days about the possibilities of linking repeaters over the internet and different ways to solve this problem. EchoLink was released in May of 2002, so just about 12 years ago. The photo there is my son Ryan, who was also released in May of 2002, so that's just sort of a time reference. And now there's nearly 215,000 users. It went from about, you typically see maybe 100 or 150 online, and now we typically have about 5,700. 162 nations represented in that. So it's become quite a large system. I think there's been more than 400,000 call signs that have registered at some time with the system over the years. And as I mentioned sort of at the beginning, there's really two different kinds of EchoLink. I call them nodes, EchoLink stations. The one that you may be familiar with is the PC user, just running it on a laptop or a mobile device that has microphone and speakers and an internet connection. But the other type is an RF link, sometimes called a node or a gateway. And it has the additional features of having a linking interface and a transceiver connected to the same software. And this gives it the RF gateway function. If you're running EchoLink on a PC, this is what it looks like. The software hasn't changed much in a number of years. It is essentially the same as it was about 8 years ago. And you have a couple different views, both of which show you a list of stations that are online. And it's just a matter of sort of a point and click to make a connection to any of those stations, no matter where they're located. In this mode, in this view, the Explorer view, the stations are organized by their call sign prefix as an attempt to separate things a little bit. However, keep in mind that this may not show the station's actual location. It's simply based on their call sign prefix. So a German station operating in the United States would still show up as Germany. Inside, there's a bunch of things going on, which is pretty much invisible to the user. The software is a single package. It's relatively easy to install. But inside, there's a number of things going on in the block diagram, which support both of these two modes of the system, the PC user and the SysOp mode, which is the RF linking. In fact, it is possible to remotely control your link over the internet or over a phone line to satisfy the requirements of the FCC rules as well. The additional piece that you need to create an RF link is an interface, which is really very familiar to you if you've done any HF digital modes, like PSK or RTTY. Really just a connection between the PC sound card and the transceiver. And the two critical connections that need to be made there, or the three, are the audio in, the audio out, and the push-to-talk line. The PC needs to be able to command the transceiver to go into transmit mode and then take it off of transmit mode. And EchoLink does that through the serial port. So a very simple interface which monitors one of the status lines on the serial port can control the transceiver. You also get an additional positive control on an FM transceiver if you have some way of detecting a carrier on the input. And most transceivers that have a packet connector on the back will have that signal available as well. And EchoLink can be configured to look for that signal on the serial port. So there's all kinds of different ways to do this, and there's various interfaces available. You can either roll your own based on a diagram like the one I just showed you, or you can buy one. And I actually have some examples of interfaces which I'll open up at the end of the presentation here. They come in various categories. They're the special purpose ones, which were designed specifically for EchoLink. Some of them even have a little EchoLink logo on the front, even though I didn't make them. They have a hardware touch tone decoder, which is a reliable way of picking up commands from a mobile device. They have a COS interface, which is that carrier detect that I mentioned. And of course, they have audio routing, so you can be fairly flexible in the way the station is set up. The other class are the generic sound card interfaces, like the rig blasters and things like that, that are designed really for any type of application. And then there's also sort of some super interfaces, which are a combination of both, but they have the benefit of the hardware DTMF detection. The other option is to buy one of these, which is a Kenwood transceiver, a TM-V71A, which actually has EchoLink built into it, or at least an EchoLink interface built into it. So with this device, all you need is a special cable from Kenwood, which connects to the back panel jacks and plugs directly into the sound card and serial port of your PC. And this is under a special licensing arrangement between EchoLink and Kenwood. They also have an HT, which is considered to be EchoLink ready simply because it has special memories for holding node numbers. Behind the scenes are a number of servers, and one of the misconceptions about EchoLink is that all of the communications between nodes, all the voice communications, are going through servers, and that isn't quite right. The communications between nodes are on the horizontal line at the bottom of this diagram. It's really peer-to-peer over the internet. That's the way the system can scale so well. The servers are used for functions of logging in and keeping track of which stations are on the system, for maintaining the list of logged in stations, and also making sure that every station that's on the system has been duly validated. It's obviously very important to know that all the nodes in the system are actual legitimate amateur radio stations or operators. And to make that happen, there's a system called positive validation. And the principle here is that proof of license and identity is required for every new user of the system before a new user is allowed to be on the system. And there's several ways to do this, the most obvious of which is to take a copy of your amateur radio license and fax it or scan it and upload it, and there's a provision on the website for you to be able to do this easily. Over the years, there have been a number of other options, especially for US users. One of them is to do a quick check on your credit card to verify that the billing address in the credit card matches the mailing address on your FCC license. There have been other options using telephone systems and sometimes postcards, and the ARRL digital ID, which is used for Logbook of the World. And for various reasons, I've phased some of those out, but there will be various options available for validation. Typically, this happens within 12 to 24 hours. It's usually pretty quick. And there's actually a pretty good representation of US amateur radio license classes connecting to the system. I think just representative of active hams around the world. It's not heavily weighted toward technician class licenses, for example. Worldwide, by the way, the United States is about 45% of those stations on the system. So the majority of stations are outside of the United States, and actually more than 30% of them are in countries where English is not the primary language. Talking about a different system now is the Internet Radio Linking Project, IRLP, which was developed by a fellow named Dave Cameron in Canada quite a number of years ago. It's been up and running now for almost 15 years, more than 15 years. It's a little bit different than EchoLink in that it is a hardware-software package. To set up an IRLP node, you actually purchase a circuit board which goes into the PC or be connected to the PC. And it comes with a DVD which contains a copy of the Linux operating system pre-configured for use with IRLP. There are about 1,700 IRLP nodes worldwide, all of which, by the way, are RF nodes only. There is no concept of a single user, a PC user in IRLP. The idea is to make it strictly about linking. If you order the IRLP package, you'll get this option card, which can fit into a PC slot, and a copy of Linux. It's actually now a CentOS distribution as opposed to Fedora. But that's really the size of it. The interface board is similar in some ways to EchoLink interfaces. It has a DTMF decoder. It has audio connections to the transceiver, although it is necessary to create a custom cable that connects to that radio and sound card connector for each type of radio or repeater that's going to be connected to it. And inside the software is actually a modular architecture, a series of binaries and scripts that all work together to form the IRLP system. The nice thing about that, even though it possibly may be a little bit more difficult to configure, is it's much more flexible. It allows you, if you're familiar with Linux or shell scripting, to be able to customize the node in all kinds of different ways. So there's lots of flexibility in IRLP. The security system is quite different. Rather than having a system of sort of master servers, which have copies of all the passwords, the authentication is done peer-to-peer using a system called PGP. Each node on the system has a copy of the master key ring of all the other nodes on the system, and it uses that to authenticate each connection that comes in. There's also a sort of a hybrid of these, which is called EchoIRLP. And what this really is an IRLP node with some additional software which will allow it to also work on the EchoLink system, although typically not simultaneously. It's almost like a dual boot thing. What that means is that if you have an EchoIRLP node, your node can accept connections either from IRLP or from EchoLink. It typically doesn't bridge them together, but allows either of them to work. So it's interoperable between both systems. There is a third system called AppRPT, and what this is based on is a Linux software package, which you may have heard of, called Asterisk, which is basically a telephone switch, a PBX, a software-based PBX. Well, what does that have to do with internet linking? Well, it turns out that any kind of a software-based PBX has VoIP capabilities built into it. So all that is needed is some additional authentication and validation and interfacing for it to be useful to us in the amateur radio community. So by taking the, by the way, freeware Asterisk system, and by adding this module called AppRPT, which stands for Application Repeater, it allows an Asterisk system to support radio linking. You use a special hardware interface with that, affectionately called a dongle. This is an example of one of them, which connects to the parallel port. Actually, it's a USB connector and then has a parallel type of connector that goes to the radios. And this creates a system with all kinds of customization possibilities, forward and reverse auto patch, and the Asterisk module itself can be used as the repeater controller. So there's lots of possibilities here. This is a very good solution, I think, if you're thinking about creating a custom dedicated system for having two stations connected over the internet 24/7, as opposed to a system that's sort of publicly accessible. There is a loose federation of these stations called the All-Star Link Network, and this allows stations to discover each other. They're running the software. The most interesting development in this recently has been the mobile computing platform. And this was fascinating several years ago. It's becoming a little bit less fascinating now that we all have one of these in our pockets. But I remember it was actually in this room at HRU about, I don't know, 4 years ago, where somebody held up one of these devices and said, "Can you put EchoLink on this thing?" I thought, how ridiculous. Why would somebody want EchoLink on their phone? But as with many things, it becomes less ridiculous over time. And now this is one of the most widely used ways to access EchoLink. You think about these smartphones, they really are pocket computers. The fact that they can make phone calls is almost ancillary. Many of us use these a lot more than making phone calls. And it really is a computer that has lots of capabilities. If you think about it, it has a fast CPU, a very sharp display, good battery life, completely portable, has radios in it for Wi-Fi and Bluetooth and GPS and cellular. And it has a sound card, if you think of it that way, microphone and speakers. So it has all the pieces that you need for an EchoLink client. So lo and behold, I created EchoLink for iPhone a number of years ago. Its appearance needs to be updated for iOS 7, but it will still work in iOS 7. And this is just sort of a miniature version of sort of a subset of what the PC software can do. It allows you to connect to EchoLink stations anywhere in the world from your pocket. The list of stations is shown on the right here, and then the main communication screen is shown on the left. You hit the transmit button to begin transmitting, and hit it again to stop. One of the challenges with the mobile devices was to figure out a way for them to interface with the internet in a way that didn't require special router changes, and I'll talk about that in a minute. But first I'll mention there is also a version of EchoLink for Android, which is also quite popular, essentially functionally identical to the iPhone version. The iPhone version, by the way, also runs on iPad and iPod Touch. The smartphone editions have been downloading pretty rapidly, about 450 new installs per week of the iOS version, and that's been going on for several years now, and nearly 170,000 installs for the Android version, with about 76,000 currently active. Android will keep track of things that are uninstalled, so I can know that at this moment there's about 76,000 copies in the wild. And one of the challenges with Android is the fact there's so many different versions being supported. There's hundreds of Android devices, and as you can see, at any given moment, there's still a fair number of people running about 6 or 8 different versions of the Android operating system. Very different story than with iOS, which makes testing of the Android version fairly difficult. We were having this conversation before. It's not uncommon for somebody to have EchoLink working flawlessly on one Android device and having some problems on another. I think there's some things I could do to improve the robustness of the software, but still it's a little bit of a testing problem. It's not possible to have all these devices to test with. I have been working on, very slowly unfortunately, have been working on an edition of EchoLink that is specifically designed for iPad. Probably will be a universal binary. This is an actual screenshot of a test version I've been working with. The idea is that there's a lot more space on the device to be able to show stations graphically on a map, and to do things like retro VU meters, which actually work. Even the peak light will flash on and off as audio comes in. And just an opportunity to take better advantage of that screen real estate. One of the challenges I'm running into on this map, by the way, is having to deal with such a large number of stations, and actually having to cluster the push pins instead of showing all of them, really to save memory mostly. So there are some challenges with it, but I'm hoping it'll come along soon. And this gets into this discussion of networking. Back in the day, when many of us were using dial-up connections to the internet, this wasn't a big issue. When we connected to the internet, we had our own, at least for the moment, dedicated IP address, and there was no firewalling, there was no routing issues because there was only one PC connected to one modem to the internet, and everything was quite simple. These are the days in which EchoLink was developed. Since that time, the way that we connect to the internet is quite different. We're much more likely to have some kind of a router in the household, which allows us to share a single internet connection among multiple computers. It's also much less likely that we'll have an IP address which we can keep for a long time. We're more likely to have sort of an internal IP address and a shared public address. These cause some issues with voice over IP applications such as EchoLink, because they need to be able to function in both directions. They're peer-to-peer applications. They need to be able to send and receive data, which is quite different than the typical experience of surfing the web, where you send a command to a server and it sends a response back. With EchoLink, you need to be able to accept connections without knowing about them in advance, unsolicited connections. The user datagram protocol, UDP, is the best protocol to use for any kind of media, any kind of streaming audio or video. It's designed for that sort of thing. However, it's not always firewall friendly. The other problem is that EchoLink was designed with fixed port numbers. It uses UDP ports 5198, 5199. That's it. And the problem with that is that it makes it very difficult to share an internet connection between two EchoLink nodes. Because when a packet comes in from the internet, the router doesn't know which PC to send it to. There have been some workarounds for this. One of them is called the EchoLink Proxy, which is a way for you to use EchoLink from inside of a firewall network, like a hotel or a Starbucks hotspot or something, and be able to sort of move half of the software to another computer somewhere else which has a dedicated internet connection. I also set up a set of these things called EchoLink relay servers, which are a little bit like proxies, but they're designed to be used with the mobile devices. And I'll show you how those work in a minute. First of all, this is sort of a block diagram of this proxy. The idea is that here's you with your laptop, you're sitting inside of a coffee shop, and all you can do is get this one port open to the internet. Well, the way this works is it tunnels all the EchoLink traffic through this one port, and then when it gets to this other PC, it then fans it out as necessary, as it normally would be if you had a dedicated connection. So it is kind of like taking half the software and moving it to the other side of this cloud. And there is a network, fortunately out there, of public proxy servers, which people have set up just for the use of for the benefit of other users to take advantage of the proxy. This is what it looks like if you go to the website. For example, this one, meatballs are not allowed. I never knew what that meant. The other concept is a relay server, which is sort of a super proxy. It has some advantages over a proxy, the main one being that it will support multiple nodes at the same time. So for the benefit of the mobile devices, there is a setup of about 6 of these, each of which can handle hundreds of connections, but with a couple of limitations. One limitation is that it's only possible to create a connection outbound. And that's typically what you want to do from a mobile device anyway. You can't receive or accept an unsolicited connection on your device. And if you've used EchoLink for iPhone, you've probably noticed this. You can connect to people, but they can't connect to you. That's because of the limitation of a relay server. The only caveat to that is that even though that it will support multiple clients at the same time, they all need to be connected to different nodes. And the reason is there's this flow table in the relay server which keeps track of who's connected to whom, sort of a switchboard. So it works flawlessly, it works seamlessly, but it has certain limitations. There are a number of things on the to-do list, and I wish I could get these done faster. One of them is to enhance the PC version a little bit so that it will select public proxies automatically rather than you having to make a choice. This is a feature of the mobile devices, which hasn't made it into the PC yet. People have suggested that there be desktop support also for these relay servers. Even with their limitations, they work quite well, and it'd be nice to be able to access those from the desktop. On the iOS side, I'd love to be able to finish up this iPad application, which has been in the works for a while, and also reskin it for iOS 7. The other change I've made to the application is to allow it to run in the background, which is the way any polite iOS or Android application should work, so that it doesn't have to be relaunched each time it is sent to the background. And with Android, there's been some changes in some of the recent versions of Android which make the menu key obsolete, and the change there is to use an action bar, and also to finish support for Bluetooth audio for Android, so you can use a hands-free device or a Bluetooth headset when you're using EchoLink, which is supported in iOS but not in Android. There is also a book on this subject, which has been around for a while. This is the second edition of the ARRL book called Internet Linking for Radio Amateurs. I am the author, and this covers a lot of the topics that I discussed today, but in somewhat more detail. It goes into a lot more depth in IRLP and also some of the innards of EchoLink. So if you're interested in an introduction to VoIP and Internet linking, you can grab a copy of this book. Unfortunately, I don't have any with me today, but you can order it from the League's website. And this is also a way to help support the system, because a couple of dollars for each of these sales goes to support the costs of running the system. Speaking of which, there is also this idea of vanity node numbers. Whenever you sign up for EchoLink, you get a 6-digit node number, basically a serial number. And those are up into the 900,000s now. However, if you make a contribution, you can choose your own 4 or 5-digit number, which is especially good for a widely used repeater node that you want other hams to be able to remember quite easily. And this actually is a way to support the costs of running the system. The main costs of running the system, which I pay for, by the way, are keeping these servers running, keeping the Amazon cloud servers running. That's really the only cost, but it's fairly substantial. And fortunately, there's just enough of activity on the vanity node numbers to be able to pretty much equal out on that, so I do appreciate that. The website for EchoLink is www.echolink.org, not echolink.com, echolink.org. The software is free of charge for all 3 platforms, and there's a fair amount of information on the website about how it works and how to install it and how to get yourself validated, how to get signed up for it. And with that, I'll open it up to questions. Yes, sir.
Just, one question. If you validated for, like, say, general and made it extra, you got to revalidate?
If you upgrade your license and your call sign doesn't change, there's no reason to be revalidated. If your call sign has changed, there is sort of a self-service way to do it, as long as it's happened within the last 6 months, I believe. You just go on and indicate, this is my old call, this is my new call, this is my EchoLink password, and the system will check the FCC database and verify that information. In the back there?
Talk about password. How to redo my entire system. And I forgot my password. How do I find my password?
Okay, the question is, how do I find my password if I've forgotten it? There's 2 answers to that. One of them is your email address hasn't changed since you registered. You can go to the EchoLink website and just say, there's a link there for password reminder, and it will email it to your email address. The other scenario, which is quite common, is your email address has changed since you first registered. The problem with that is if that's changed and you've forgotten your password, we have no way to verify that you really are who you are. And if that's the case, you need to be revalidated using one of those mechanisms, for example, sending a license copy.
Second question was, you had stated a couple of years ago, many times I'll go on EchoLink and it'll be so-and-so is like online,
Yeah.
and I'll hit that on to register with that person, and I get nothing. I mean, a lot of the times I QSO somebody on the line and I get nothing in response. How do I know whether or not that person is active or not active or?
All right, there's a couple. The question is, sometimes I try to connect to somebody and it doesn't work, or I get no response. There's a couple of different scenarios there. One of them is that due to some kind of a networking or firewall issue, the connection was not successfully established to the other end. It's actually fairly common. A lot of people don't have their routers set up correctly, but they'll still show up online. No fault of yours necessarily, but that's why it works with some stations and not others. The other thing that can happen, of course, is you can have a successful connection with another station, but it seems like there's nobody there. And that may actually be the case. It may not be anybody there. Just like going on the repeater and saying I'm monitoring and not hearing a response. It's not that different. I have been considering a feature of the software which will let stations that are sort of calling CQ be able to find each other. Sort of a internet dating service for EchoLink. Which I think might be useful in some cases, but hasn't been fully developed yet. By the way, the reason for the microphone is that we're streaming the audio, so even if you don't want to be heard here, you can be heard elsewhere. Yes?
In a conference, how can I change the conference name?
All right, I didn't mention that there's another type of node in the system called conferences, which are basically reflectors that have things that don't look like call signs, that begin and end with an asterisk and have some kind of a nickname. We unfortunately signed up too many of these conferences. So they became sort of a dime a dozen and became very hard to manage in the database since they're not really associated with a specific amateur radio call sign. I'm hoping that we'll put some structure around that someday and be able to decide which conferences should stay and which should go, and to have more rules about when and how they can be renamed. But right now the conference system is pretty much frozen. So there isn't any easy way to do that at the moment. Sir.
All of your hardware descriptions seem to be talking about serial and parallel interfaces. Have you updated this for USB, or do you just have a secret stash of old computers?
Secret stash of old computers. No, fortunately with USB, the solution has been to use a USB to serial interface, which is not any more expensive or complicated than a strict USB solution. Keep in mind that I developed the software. I haven't really gotten involved with any of the hardware development. That's done by others. So any kind of a change to that specification would require some kind of cooperation. And I think that the USB to serial interface has worked out pretty well in just about every case. Yes, sir.
Yes, what is the procedure for speaking to 5 countries through a conference mode at the same time? Do you do a conference mode and then the five call signs, or do you start with contacting 5 call signs and go into conference?
So the EchoLink software has has a system called conferencing enabled, which is off by default. If you check the box, it turns it on. And that allows your node to connect to more than one station at a time. So that puts you basically in conference mode. One way to do that then would just be to, in series, connect station 1, station 2, station 3. However, it's good etiquette to make sure those stations wish to be conferenced together before you do that, because it'll basically create this connection where everybody can hear everybody, and that may not be desirable.
Yes, sir. You said for EchoLink you have certain ports assigned to work with EchoLink.
Yeah.
A lot of times routers won't allow a certain port to be accessed as blocked. Is that where you're going to have to use port forwarding in your router or something to that effect?
Yeah, so it would almost always require port forwarding when you set up an EchoLink
Well,
node.
you explain port forwarding. I'm sure a lot of guys don't understand what that term
Okay,
is.
well, it comes down to the issue that I touched on before, that when a packet comes in from the internet, the router needs to know where to send it. If you have multiple PCs connected to the same router, the packet doesn't have any information about which PC it should go to. The router doesn't know which PC it should go to. However, the router can be set up with a rule that says any packet that comes in on such and such a port should always be sent to such and such a PC. And that's known as a port forwarding rule. In other words, if a packet comes in on port 5198, I want to send it to the PC on 192.168.1.1, which is the one in my basement or something. That's a port forwarding rule. Unfortunately, every make and model of router is quite different in how to set this up. You might not even realize you have a router because Verizon set it up and you don't even know you have it. It belongs to the company. But trust me, there is a router there, and there probably is a way to set it up for port forwarding. I would love to have a world where we didn't have to do port forwarding. The problem is that it is extremely difficult to retrofit in a backward compatible way the software to work with dynamically assigned port numbers. It would require everybody to throw out the software they have and upgrade to the new software. And that would be hard enough if everybody was running EchoLink. But the problem is people are running EchoLink, they're running AppRPT, they're running the bridge, they're running Echo IRLP, they're running SVX Link, and who knows what else. There's lots of software in the system, and it would all have to change in a pretty fundamental way if we were to solve this port forwarding problem. So it's extremely difficult. It's more of a deployment challenge than it is a programming challenge.
Are you designing the upgrade for the iPad, the maps? Are you doing anything in the future for the Androids with the maps?
It's a good question. It certainly would be nice to have an edition of EchoLink which took advantage of the space on an Android tablet. In terms of development priorities, it probably isn't real high. I know those of us who have Android tablets love them, but we're a very small minority. I'd love to be able to get some of the other things on the wish list done first and then possibly tackle that later.
If I wanted to hook my repeater up to the internet via EchoLink, what sort of bandwidth do I have to set aside on my internet connection for your...
All right, great question. The answer is not much. Remember, EchoLink was designed initially to work on dial-up modems, which are like 14.4 or 19.6 modems. So it only uses about 13 kilobits per second per connection. Slightly more than that, maybe 15 kilobits, which is really just a trickle by today's standards. But you have to multiply that by the number of stations that you want to conference at once if you're running conferencing. So it's a very small number, and it's very unlikely to put a big dent in your monthly, gigabyte usage allowance.
Is the Asterisk version only for amateur radio?
The Asterisk AppRPT can be used with any radio service at all. It's not really regulated or controlled in that way. There's no restriction on that. I think that in order to join the All-Star Link network, it is expected that you're running an amateur radio station, but it would be equally valid to run a system of stations that were on GMRS or something else, or even on a public safety frequency, if you were authorized to do that.
You need to have static IP addresses or dynamic addresses okay?
Dynamic addresses are okay. EchoLink keeps track of IP address changes per call sign. You might get a little bit of a speed bump right at the moment that your IP address has changed for just a few minutes while the system catches up. So it's slightly better to have a static IP address, but it's not a requirement.
Did you use an iPhone instead of a handheld? With EchoLink?
Sure. So you would just install the EchoLink application from the App Store on the iPhone. And then you're basically functioning as if you were sitting in front of a PC. You're sort of an off-air connection to the system.
Could you respond back and forth to a net, say?
Sure. Yeah. Yep. I can demo that while we're talking here. Yes.
You mentioned needing serial connected. If the interface between the radio and the computer, Rig Blaster for one, is using a USB port, will it work? Or must you have the converter?
So,
at this point, if I want to do PSK31,
right.
my Rig Blaster connects to my radio, and we're going back and forth.
Right.
And
So
it's going through its USB port.
Yeah, so the connection would be very similar. Probably what's happening in there, since virtually all the software that I'm aware of for PSK31 expects a serial port, what's happening there is it's emulating a serial port.
Yeah, I'm making that assumption.
Right, so the same assumption then is made by EchoLink. So it will work the same way as your PSK31 software. So whether the USB to serial conversion is happening in an adapter cable or inside the Rig Blaster, which I think the latest versions do, it's still occurring either way. I think we're probably right at the end of our time anyway, so thank you very much.
Run test mode,
Yeah.
and it passes all the...
On behalf of the Ham Radio University Committee, once again, we thank you for coming down again this year and for making the nice long drive.
Thank you. Thank you very much.
It passes the test.
Yeah.
Does that mean I'm on the system and somebody who a node that I click on should be hearing
Yeah,
me?
yeah.
That means I've gotten through the firewall.
That means your end of it is probably good.
Okay.
Yeah.
Thank you.
Sure.
Is this presentation available on your website or something?
There may be a version of it. I think that they actually just